All right, so as Mr. Roy mentioned, he talked about different ways we're going to solve systems. Okay, we're going to be working on solving systems for this academic week and probably the next couple. How did we solve systems yesterday? What was the method that we used? Shannon?
Graphing.
Yeah, we used graphing. All right, so my question is, what is difficult about graphing? Why could that approach be kind of hard to do? What makes graphing hard or time consuming? Yeah? Yeah, if you had very, very big numbers, if your lines crossed at when x was like 1,000, you're going to need a huge grid, right? What other kind of numbers could be difficult to work with besides just big numbers? Yeah. Yeah, fractions. If you've got a grid and your lines cross at like 2.7, you're never going to see that graphing it by hand. That's too precise. It's hard to figure that out. So the answers can be decimals. That makes it difficult. The other thing with graphing is you need something straight. Okay, you need some kind of ruler or something straight, and you've got to have graph paper. The approach we're going to do today, you don't need anything special for paper. You can use any paper, and you don't need a ruler. Okay, and you guys already mentioned this. Your answers could be big numbers that could go off the graph. All right, so all these reasons are reasons why graphing isn't the best way to do it. Okay, still something you're going to go over for the test, but not something we're going to focus on anymore. Okay, so the second method we're going to look at is substitution. Okay, and Mr. Roy is going to go over the steps that you have to use for substitution. Okay, today, we're going to look at simpler substitution problems. Tomorrow, we're going to look at ones that have one extra step.
So guys, on your guided notes, right? What is the first after we have all the it says solving linear systems by substitution. What's the first thing it says? Situation 1. All right. So, like Mr. Hager said, we're going to use some simpler substitution problems today. Biggest thing, you make sure you guys fill this in on your sheet, no rearranging. That means either x or y is already going to be isolated. It's already going to be by itself. It'll say x equals something or y equals something. All right? So x or y, the variable, will be isolated by itself on the left-hand side of the equal sign. It'll be all ready to plug in. All right? For whatever variable you're gonna plug it in for in the other equation. All right, so it's already isolated. It's gonna be by itself on the left-hand side of the equal sign. Like before when we graphed, we did slope-intercept form, right? When we do slope-intercept form, what variable needs to be isolated? When we do slope-intercept form, what variable needs to be isolated so we can graph? Shannon. Y needs to be by itself, right? We need y, then we need the equal sign, then we need the number with x, and then we need just a plain old number at the end. So when we do these ones today, all right, we're going to be looking at the variable that's already isolated. You're going to use the information from that variable that's already isolated in the other equation. Because remember, we're talking about systems, so we're going to have more than one equation. We're going to have two. All right, so that's the situation. Now tomorrow we'll get into some stuff where you're going to have to move some stuff around to get x or y by itself, and then it'll be set so then you can substitute it. But today, none of that. This is simple stuff. All right. So first thing, kind of long, but we'll write the step out, and then after that step, we'll do an example that goes along with it. Okay, so we'll write the steps and we'll work an example as we go so you can see each step on your notes. So first thing, find the equation that has the variable isolated. It has x or y by itself. All right, before the equal sign or on the left-hand side. All right, I want to put parentheses around the information after the equal sign. So anything that comes after the equal sign of that variable of the equation as the variable already isolated, I'm going to put parentheses around it. That's going to help me to match it up when I have to actually substitute it. Like I said, every equation that we deal, every system we deal with today will have at least one equation that already has x or y isolated by itself. So you won't have to move anything around. There'll be no rearranging. Like I said, guys, for each part or each step that we do, right, we'll do an example that will show what's happening in that step. So you guys have, I'm going to leave this up here, guys. I'm going to scroll down a little bit. You guys have this same example on your guided notes. So, someone tell me which equation has the variable that's already isolated, the top one or the bottom one? Bay? The top one. What variable is isolated, babe?
X, we know, Y.
Y. The x wouldn't be isolated because it's over here and it has stuff with it. The y is isolated. It's on the left-hand side of the equal sign. There's no number attached to the y. All right? There's nothing else. It's what I want. So for this system, the y is isolated. The y is by itself. So, what do I need to do? What do the directions tell me to do? We just wrote all those directions, so we need to make sure we understand what they mean. What do I need to do? Shannon?
Put parentheses around the info that has
So what is that info?
negative 3x plus 5.
Negative 3x plus 5. I'm going to put parentheses around negative 3x plus 5. On your sheet, on your guided notes, that's all you need to do. Is just put the two sets of parentheses. All right? That's all I'm doing. That's all I'm doing. For that step, for the first step, find the variable that's, and sometimes, guys, we may do ones where x is isolated. All right? It's not always going to be y. It could be x. All right? And I'm going to put parentheses. That's exactly what these directions say. All right? I'm going to move down to step 2. So, I'm going to put it in the other equation now. Now I'm talking about the other equation that's there. So for this example, it would be the bottom one. I'm going to put parentheses around the isolated variable in the other equation and plug in information that already has the parentheses. All right? So what I'm doing here is my variable that's isolated is y. I want to put parentheses around y in the other equation. So I'm looking at whatever variable is isolated, I want to put parentheses around that variable in the other equation. All right? So I'm still going to keep, I already did step 1, I already got my parentheses around the top one, because that had the variable that was already isolated. Now, I want to look at this variable, the one that's isolated, and put parentheses around that variable in the other equation. So, what do I need to do in the bottom equation? Someone tell me about raising their hand. In the bottom equation, someone besides Shannon, but thank you, Shannon. Somebody maybe I haven't heard from yet. What do we need to do in that bottom equation? Which letter should I be putting my parentheses around? Meaning? The y, right? I'm also going to take in the plus sign too, because it's a positive y. So I'm going to put parentheses around the y. Now see how my parentheses, I got this set of parentheses and that set of parentheses. And we're going to talk about that a little bit when we get to that next step. All right? So what I did here was I took the variable that was isolated in my top equation and I put parentheses around it in the bottom equation. That's going to help us visually to write what we need to do. All right? Now when I get to these next steps, I'll leave this up in case people are still writing. So now, I'm going to solve, all right, I'm going to solve the equation with the information from the parentheses plugged in. Big important thing here, guys, is it should only have one letter. The variables in that equation should be the same. It should be x's or y's. You shouldn't have an x and a y. You won't be able to solve it that way. It has to be the same. You're going to have some, you might have just some whole numbers, but the variables that you have for the whole equation either have to be x's or y's. You can't have both. That means you set it up wrong.
So wait, let's leave that plus sign outside the parentheses.
Okay.
Just because if it's a negative, you have to distribute it.
Okay.
You know what I mean?
Yep.
Yeah. Just a small change, guys.
Yeah. You're right, Mr. Hager. All right, so we're going to plug in, we're going to solve the equation with the parentheses plugged in. So now we actually going to have to, now we need to like set it up. All right, so let's scroll down a little bit. I'm going to leave this up here. So now, I got my two equations. I'm changing the bottom equation. I don't have to worry about the top one, the one that has the variable already isolated. I'm not doing anything with that. Look at my first term, my negative 6x. It has no parentheses. It has nothing. Nothing needs to change there. It stays exactly the same. It stays as negative 6x. The plus sign, it stays there. There's no parentheses around it. It doesn't need to change. I'm just going to put a plus. Now I get to the fact where I need to start changing. It's like I'm at the point now where all I want to do is match up my parentheses. I don't want that y there anymore because I only can have x's now. That's why I'm substituting. Does anybody think they might know what I'm going to write after that plus sign? Liam.
3x plus 5.
Negative 3x plus 5. I'm going to write it in parentheses. It's just a good habit to be in. All right? So I plug that in. All right? This came here. But there's still more to do with this example or with this bottom equation. I still have to write in the rest of it. All right? So I took this, I matched up my parentheses. The information from this parenthesis is going down here. All right? So this information is being plugged in for this variable in the other equation. Let me say it again. This information is being plugged in for this variable in the other equation. That's what substitution is. Then I'm just going to write in the rest of my equation. Equals negative 1. That's all I need to do. Now, I got my parentheses here. I can rewrite it because I can say there's a 1 there to distribute, but it's not going to change anything. So if there's a positive sign outside your parentheses, it's not going to change anything. This is still going to stay as negative 3x. That's still going to stay as positive 5. So all I'm going to do right now, guys, is just rewrite it without the parentheses. All I did was rewrite it without the parentheses. That's all I did. I mean, I can multiply positive 1 times negative 3. I get negative 3x. I can multiply a positive 1 times a positive 5. I'd still get a positive 5. So if there's just a plus sign outside your parentheses, it's not going to change anything on the inside of your parentheses. Nothing happens. Now here, my steps, for the most part, are always going to be the same. What can I do at this point now? Because now I've done the substitution part. Now I'm just at a point where I have to solve. Josh? Combine like terms. I'm just going to put a little CLT right here so you guys know the step. You're always going to have to do that. You're always going to have those variables on the same side. So you're going to combine them. So what are my like terms? And make sure you include the sign. All right, Kyle?
Negative 6x, negative 3x.
Negatives. I got a negative 6x and a negative 3x. When I combine them, what do I get? Don't change it to a positive because you're not multiplying or dividing. All right? You're not multiplying or dividing. Aiden, what do you think you get? Negative 6 and negative 3. Negative 6x and negative 3x. No. No? Vanessa? Negative 9x. Guys, and this is stuff we've talked about since the beginning of the year. If we have the same sign, we have a negative and a negative. Keep the sign and add the numbers together. I kept the negative and I added 6 and 3 together and I got 9. And I got to make sure I bring the variable down with it. Those x's are just there to say, hey, you can combine the two of us. I'm going to bring down my plus 5 because there's nothing I can do with it. And the negative 1. Next thing I want to do is isolate. I'm going to isolate the variable. Anybody want to tell me what that means? What do I mean by, we've talked about that a little bit. Liam. Get it by itself. If there's anything on the same side with it, I got to get rid of it. I got to move it to the other side. Easily. I get that. So what do I want to isolate? Which is? What is the x in this problem? Huh? What's attached to it? Yeah, negative 9. I want to isolate that. You're right. I just want to make sure you know you could see it. All right? I want to isolate this. All right? I want to get that. So that's basically what that's saying is that's not moving. Do not move it. That's going to stay put. So to isolate that, Emily, to isolate that negative 9x, to get it by itself, what needs to happen?
You have to subtract 5.
Subtract 5. That's going to get it by itself. So I subtract 5. Emily, where else do I subtract the 5 from?
On the negative 1.
The negative 1. Very good. I'm going to bring down the negative 9x. There's nothing I can do with it right now. Equals. Now, just like we talked about up here, we had 2 negatives, right? We're not multiplying and dividing. So when I combine those things, what do I get? Anybody know when I combine those things, what will I get? Marissa? Negative 6. All right? Now I think this last step, we've done this a bunch of times this year. I wrote every step, right? Combine like terms, isolate the variable. Now I'm on the last step. We've done this before. What do I have to do? Ashley? Divide. That's my last step. And guys, for the most part, these steps, once you substitute, these steps are going to be pretty much the same every time. All right? I'm going to divide by Ashley. What number? Negative 9. Negative 9. This cancels out. Leaves me with x. Now, I got a negative, and I got a negative. What's going to happen now? Positive. Why? What math operation am I doing again? Division.
Sorry.
All right? But can negative 6 go into 9 evenly? No. What can I do though? Does anybody else think they have an idea what we could do? Josh? I can reduce it. When you reduce it, what do you get, Josh? Do you know? Not negative, but I like the number you said. Positive what? 2 over 3. Very good. Nice job, Emma. 2 over 3. All right? Because I could just reduce that. I could divide both the top and the bottom by 3. I know 3 goes into both numbers. So I get x equals 2/3. Little bit tricky because you got a fraction. But we can still do it. And guys, just because you got a fraction, don't stop. All right? So how many people at this point now agree we're done with this whole, we've solved by substitution, we're done? How many people agree with that? How many people say we're done? All right. Maggie says we're done. Who says we're not done? Why? Oh, more steps on the paper. Okay, that makes sense. All right, but think about what we've said yesterday. When we solve a system, yeah, what am I missing, Josh? What did I just solve for? X. Now, I just said it, you need Y. All right, we got X, now we need Y. So now, plug in the number we just solved for, all right, 2/3, into the other equation for either X or Y, all right, depending on, because like I said, Y is not always going to be isolated. Sometimes there'll be an example we do today, there'll be an example on the homework where X is isolated, where X is by itself, and you're going to have to move it, all right? Depending on what letter you solve first. So now, in this case, the bottom equation was the one that we changed, because the top equation had the isolated variable. Now, we're going to go back to that top equation that had the isolated variable, and we'll use that to solve. Right, Mr. Hager just brought it down for us. All right, so now we're going to use that top equation, which is y equals negative 3x plus 5. I'm going to go back up a little bit. Now, when I just solved here, right, this x equals 2/3, do I have a variable that's isolated now? When I solve? Yes. When I solve, what variable is isolated? The x is isolated now. And in the first step, what did I say to do when you have an isolated variable? Anybody remember? If you're not sure, look on your notes. What did I say to do if you had an isolated variable? Put parentheses. So, Emma, what should I put parentheses around? No. What variable's isolated when I just solved for? Look what Mr. Hager circled. The x. What should I put parentheses around? Up here, what Mr. Hager circled. The stuff after, right? The 2/3. I'll put parentheses around that. Now, I got to look down here. And Mr. Hager already drew a line coming down. What else should I do? Meaning?
Parentheses in negative 3x.
Careful.
Negative 3x.
What's the only thing? What's the thing? We put parentheses around the 2/3, right? What's the letter next to 2/3? X, right? What should you do down here? What should I put my parentheses around? No. Anybody else think they might know? What am I going to put my parentheses around down here, Marissa? Just the x, not the negative 3. I'm only where the x is. I'll put parentheses around that. So now I'm going to start with y equals. Anybody think they might know what I'm going to write after y equals? Kyle? Yeah? Yeah. Plus 5. I did the same thing. When I solved, I had an isolated variable, which was x, put parentheses around it, and I found this variable in this equation and put parentheses around it. Then it's just a matter of taking what I had parentheses around, what was isolated, and plugging it in for that number. All right? So now I'll just do it. If you don't have Mr. Hager, do it over here for me. He's doing the whole thing. All right, so he's going to get y equals 3. There's the work right there. Was there another step on there, guys, or no? Do me a favor, don't copy this. I want you to, answer should be written as, I don't want to write it as a coordinate, or write it as, not mistaken. We want to write your answer as, we don't have to write it as a coordinate today. That's the one when we did graphing, because we had an actual coordinate on the graph. For this, we just want to make sure we write x equals or y equals. Or on the test on Friday, if it was a multiple choice question, all right, it's going to be written as x equals, for this problem, right? If I was going to write my answer the way it says here, written as x equals y equals, what would I write? So y equals 3 and x equals 2/3. All right, so I'll go down here, x equals 2/3, comma, y equals 3. That's substitution. And again, remember, today, like I said, once you guys get caught up on that, today, like I said, we're not doing any rearranging, which means you don't have to get x or y by itself. It's already going to be by itself. All you do is find the one that has the variable isolated, parentheses, and plug it in. That's why, guys, not so much on this one, but in the warm-up, we did distributive property, because when you have a number, like if I was plugging in, like say if I got x was y plus 3, then I'd have to, then the next ones we'll do, you'll see, we'll have to do distributive property. That's why we did a little practice with the distributive property in the warm-up.
Anybody still copying them down? All right. All right, so same directions as last time, solve the system. Who can tell me what I should do first? What's step 1? Is that a yes? Yep. Yeah, where should I put parentheses, Emma? After the equal sign? Can you tell me which equation? For the top one, right? Because this one is the one that has the letter by itself. Okay, what's the next thing I do? Yep. Yeah, what did we put it on the y first? But that's exactly what you're going to do. Yeah, just to kind of remind us, this is where it goes. So that...
You guys, you can draw a line too, like Mr. Hager does. That's fine too.
Okay, so any questions on those first 2 steps? All right, so now if we do what that arrow says to do, can somebody tell me what my new equation will be? Kyle?
6x minus 5 parentheses
Yep.
minus 2x negative 9 parentheses.
Yeah, that's the biggest thing, guys. Don't even once you substitute, you're not done. You still have to write the rest of the problem that you're plugging into, or that you're substituting in.
And now in this equation, what letter are we going to solve for now? We're going to solve for x right now. And then once we have x, we're going to use that to solve for y. We'll just have to fill it in once we know it. Okay, who can tell me what's the first thing I have to do on the left-hand side to simplify? Begins with a D. Yes, distributive property. We have to be very careful. What are we distributing? I heard 5 and I heard -5. It's the negative. Okay, that sign to the left of the number always goes with it. What's going to happen to the 6x? Anything? Is that going to be affected when we distribute? No. How about the -19? Is that affected? Is that affected? What'd you say, Sally? I put it in the wrong spot. Oh, the color? I did? Oh, okay. So that -19, is that affected by the distributive? No. Okay. So I'm going to write that down. And I can write that down. Those aren't going to change. Now we have to do our distributive. What's -5 times -2x? Think of -5 times -2, and then add an x on it. What is it? Multiplying, we're not adding. 10x. -5 times -2, is positive.
You put that plus sign.
10x. Okay, how about the next one? Negative 5 times negative 9. Positive 45 or negative?
Positive because it's a negative and a negative.
A negative times a negative is a positive. Great. Somebody see what I can do next on the left.
Like
Like
step-
terms.
Yeah, combine like terms. Emily, what were you going to say? What?
I was gonna say that.
And what are the like terms?
6x and 10x.
Yep. 6x's, we have 10x's, and what do you get if you combine those together?
16x.
So 16x. Everything else, we'll just keep it the same. Okay, there's no more combining like terms, but now we can isolate the expression that has the variable. Okay, so 2 steps left. What would be my next step? Yep. I have minus 45.
Isolate that variable.
Okay, and then negative 19 minus 45, you could just use your calculator. You get negative 64. And my last step, at least to get x. Yep, Ashley? Divide by 16. Now, that's going to come out nice. Does anybody know what that comes out to? Negative 64 divided by 16? If not, we'll just type it in on the calculator.
Josh knows what's there.
Yeah. If you divide it, it's going to be negative 4. Okay, so I'm going to circle that. And am I done? No, I've done the hardest part, though. I've done the part that probably has the most work in it. What do I still have to do? Yeah, I still got to get y. So how do I use what I just circled to figure out y? How do I do that? Shannon?
You substitute it into the first equation.
Yeah, for what letter?
X.
Exactly. You're going to take this, plug it back into the first equation for x. Okay, so if I do that, can somebody tell me what that top equation will look like doing what Shannon just said? How about Trent? Can you tell me what that would look like?
6 parentheses negative 4.
So are we plugging into the top equation or the bottom? Where is this negative 4 going? Follow the arrow.
Oh,
Top one.
y equals
There you go.
negative 2 parentheses negative 4
Yep, perfect.
minus 9.
Minus 9. So you put parentheses around that negative 4. You always should do that anytime you plug in. Okay. Next, I have multiplication and subtraction. What do you do first? Multiplication. Derek, what's negative 2 times negative 4?
8.
Yep. So we have 8. Now we almost have y. We just have to do 8, take away 9. Okay, what's 8, take away 9? Negative 1. So if you were to draw these two lines, let's say we graphed them like we did yesterday, where would they cross each other? At what point? Negative 4, negative 1. That's exactly where they would cross. So now that you guys have done a couple substitution ones, which way do you like better? Do you like graphing it, or do you like this method? Graphing? Most people like graphing better? Yeah.
Well, this is like a lot more time.
This one takes more time?
Yeah.
Yeah, it depends on how they give it to you. If you ask me to graph something like this, it's going to take me a little while to get y by itself first, because we're going to get it in y equals mx plus b. You don't have to do y equals mx plus b here. So you save time not having to do that. But, yeah. All right, so we'll try, maybe try one or two more together, and then I think we've got some extra ones at the end. You guys we'll give you time to try a couple on your own. Okay, what do we have? Up to F? Yeah.
For that one, do you want to maybe just give them like a minute and just see if they can at least identify what variable to isolate and then set their parentheses up and let's kind of walk around and check?
Okay? Sure.
Do that. So guys, for this one, all we want you don't have to plug stuff in yet. All we want you to do is identify which put parentheses around the information that has the isolated variable, and then match it up, put parentheses around the variable that you're going to substitute for.
Okay, so guys, which equation, top or bottom, already has a letter by itself? Bottom. What letter is by itself? Y. So I'm going to put parentheses around all the stuff that's I'm going to plug in. Now, 1/2 x minus 1, what does it say that that's equal to? What letter? It's equal to what, Emily?
To X, Y.
Yeah, all that stuff I just put in parentheses in blue is equal to y. So what letter up above am I going to put in parentheses? The y. That is what's getting plugged in. Okay. Questions on that? Okay, so that's how your parentheses on your paper should look. If they don't, fix them. Okay. Now, who can tell me what it will look like once I do what it says right there? Yep, Nini? Yep. Equals 0. So we took everything that was in the bottom, 1/2 x minus 1, and we put it in right where the arrow says to for y. Okay. Now, what property do you pretty much always have to do next if you have a number in front of the parentheses? You always have to distribute. Okay. And what am I distributing this time? A positive 2. Okay, so we'll do that out and see what we get. 3x, that's going to stay the same. What's 2 times 1/2 x? Josh? 1. 1 what? 1x. So instead of 1x, could I just put x? Yeah, it's the same thing. And then 2 times negative 1. Antonio?
No, 1 is -2.
Negative 2. Okay, now my next step. What do we always do? We've had to do it in the last 2 problems after the distributive property. Combine like terms. Okay. What do I get if I combine like terms here? 3x plus 1x is 4x. And now we're down to an equation that has 2 steps left. And then you'll know x. Kyle? Perfect. Add 2 on both sides. And Kyle, what's 0 plus 2? 2? So I have 4x equals 2, but I want just x by itself. So how do we get rid of that 4? About done. How do we get rid of that 4? Yeah. Divide by 4. Divide by 4. So we got x by itself, but does anybody see what you can do with this fraction? 2/4?
Slide.
Yeah, what does that simplify to? Yeah, it's 1/2. Okay. Questions on how we got x?
Someone tell Mr. Hager what we're going to do next. Shannon.
Substitute 1/2 for y, or for, yeah, y.
For y.
For x.
For x. And then that'll give you.
We'll give you y.
Okay, so let me scroll back up, find my equation that had y by itself.
Always go, yeah, we'll what we do today or tomorrow, you're always going back always go back into the equation that has the variable isolated to get your other variable, to get your other answer.
So now filling in x in that equation. How come I didn't just fill in x right away? Why didn't I just do that as my first step? Huh? I didn't know it. Now I know it, so I can fill it in. That's why I didn't do it right away. So Kyle, can you tell me what this equation will look like if I fill in x with what we just solved for?
3 parentheses 1/2 plus 2y equals. Oh, what?
Plug it into the bottom equation, Kyle.
So Kyle, you're not wrong. Technically, you can plug into either equation. It's just that I think the bottom one is easier because the y is already alone. But the top one would work.
1/2 parentheses 1/2
1/2 parentheses. Yep,
minus 1.
-1. Okay, so let's see if we do this part without the calculator. What's a half times a half? 1 what?
1.
Not 1, that'd be if you add them. What's half of a half?
A fourth.
A fourth, right? Or a quarter. And then if you have 1/4 and you take away 1. Anybody know what that is? Yeah, it's going to be -3/4, so you can plug in on your calculator. This is probably as bad as the fractions will get with denominators of 2, 4. You're not going to have something with like a denominator of 17. That would be kind of a weird fraction. And that's your system. So if you were to graph these two lines, that's where they would cross. Would this be an easy one to tell graphing? How come this would be hard to get the answer graphing? It's all fractions. I mean, if you draw it, unless you draw it really, really pretty good, it's going to be hard to tell if they cross at a half and -3/4. Okay? That's why this method it's a little bit better if you have decimals. Okay. Any question on 1C? All right, so let's do 1D the same way we just did 1C, and then we'll give you guys time at the end to do E and F.
Yeah, so say from 1D, you want them to go through and put their parentheses, and then they don't have to solve, but just write out the equation?
Yeah,
Okay.
just do the same thing you just did, and this one actually is a little easier.
Yeah, so identify the variable that's isolated, all right? And then do the parentheses thing, and then I want you to write out your first equation to solve for one of the variables.
Hey guys, let's take a look. What's different about this equation?
They're both.
Both what?
You can both set them up.
What do you mean you can both set them up?
Sure can.
I don't know.
They both have the
I was going
variable
somewhere.
isolated.
That's the Italian.
They both have
Both set 'em
isolated.
up.
All right, so Emma, can you say that again?
They both have the y on that side neutral else.
Yeah, both equations have the y by itself. So pick one of them. Do you want to put parentheses around the top one or the bottom one? It doesn't matter. Top. So we're going to take everything we just put parentheses around, and where is that going to get filled in? For what letter? Josh? For y. Okay, so plug that in. Natalie, can you tell me my equation if I do what that arrow says to do? Yep, 3x plus 14 equals -4x. Okay, so when both equations are equal to y, like this, pick what's on one side and then plug that in for y. How many people had an equation something like this? If you had it -4x equals 3x plus 14, that's okay too. All right, so who can tell me my next step? I want to get all the x's on one side, right? So right now, we have things without x's on the left. So we have to get things with x's
Boys over.
on the other side. Josh? Yeah, we'll subtract 3x. Subtract 3x. Now you just got rid of all the x's on the left. What's the only thing that's on the left-hand side now? 14. What's negative 4x? Take away 3x. Somebody said it? Negative 7x. And what is my last step? Yep, divide by negative 7. So this time we have x on the right. Is that okay?
Yeah.
That's fine. Same thing. What should I have on the left? About, Kaylee, what should I have on the left? Yeah, what number? That's cancels.
7. Negative.
You said 7? Or negative 2, yeah. Okay, so x is negative 2. Okay. Any other questions on that one? So what do I do next? How do I finish this up? Plug it in for what? Where? I don't know which one.
He's actually telling you which one. Don't give him sass, just tell him where it goes. Yeah. Wait, I'm gonna go with, the top one.
Okay, let's do the top one. And Antonio, what do you get if you do the top one? Y equals,
parentheses, no parentheses.
it's okay, you don't need them.
Okay, 3 parentheses, negative 2 plus 14.
And if we do that out, 3 times negative 2 is negative 6. What's negative 6 plus 14?
8.
8. So we get y equals 8. Let's see what happens if we did the bottom one.
Yeah, I would have chosen the bottom one.
What if you did the bottom one? How would you write that one out? Kyle?
Y equals negative 4 parentheses negative
Negative 4 in parentheses negative 2. And what's negative 4 times negative 2? 8. How does that?
Yeah, you're not wrong choosing the top one, but why would the bottom one be a better option?
It's smaller.
It's smaller, it's less steps, right? In the top one, we had the multiply and use addition. In the bottom one, we just had the multiply, that's it. There's only one step, it's less steps.
So how do those two answers I just got compare? Same thing. So that means, like Mr. Roy just said, it doesn't matter which equation you use. Pick the easier one. Okay, pick the easier one. All right, so somebody tell me some important things coming up this week. What do you have to do this week? Test
That's
when?
Friday.
Test on Friday.
Review Thursday.
What's special about this test?
It's the only test on our progress report.
Only test on the progress report. What else is going on this week?
Yes.
Bring your Chromebook Thursday, because what are we doing on Thursday? MCAS, and then if we have a little time, we're going to review. And yes, the homework tonight will be 5.2.
5.1.